Hello everyone, I am Liz Party from NodeSource, the makers of NSolid, the best way to monitor and secure your Node.js applications. I'm going to give a brief introduction of our exciting release, the NSolid C++ API. But first, let's talk a little bit about NSolid. If you haven't heard about NSolid and you use Node.js, this might be very interesting for you. And if you already use NSolid, you should check out this new feature. So, what is NSolid? NSolid is a drop-in alternative to the Node.js runtime. In other words, it's the same Node.js that you're familiar with, but it's augmented to deliver unparalleled insights and greater security for Node.js applications without any performance impact. One of its key characteristics is the minimal overhead it causes, unlike any other traditional APM tools. Plus, it doesn't require any instrumentation of your code, saving organizations a lot of time and costs. So while traditional APMs occur in an overhead range from 5 to 20%, and it makes your application slower, NSolid overhead is less than 0.5%, and it gives you the best metrics without sacrificing performance. Now let's talk about this exciting release. The NSolid C++ API allows to get the full NSolid features without additional performance costs that other APIs can have. Thanks to this API, you're not restricted to use the supported backends anymore. Whether it's the NSolid console or stats.d server, you can implement your own agent as a native add-on to integrate with your preferred backend solutions. It is still in beta, so expect some changes or improvements in the following weeks. You can now check the API documentation in this link. Regarding the NSolid C++ usage, the most important thing to take into account is that in order to get the best performance, we need to avoid interfering with the runtime JS threads as much as possible. The recommended way to accomplish this is twofold. First, make the API calls from a separate thread. This is possible because of all of the API methods are thread safe. Second, process the data received from the API in a separate thread as well. So imagine we're gathering a set of metrics from the runtime and we want to do some processing before sending it to the backend. What we would do is to pass the data received from the API to a separate thread to perform the processing there. Next, I'm going to show a basic example of an add-on which spins a new thread from where it retrieves its specific metrics from the main JS thread, and then it takes a 5-second CPU profile from that very same thread. Going to the code now. First, we look at the add-on initiation function. This specific add-on will only work if required from the main JS thread. In order to make that check, we use the NSolid thread ID method. Next, a new thread is created where all the processing will be performed. This is important in order to take full advantage of the API and not causing any performance degradation in the JS threads. In the thread run method, we'll set up a libv event loop with an UV async handle that will be used to communicate with this thread and 3-second recurrent timer. Finally, we'll start the loop. In the timer callback, the first time we will collect metrics from the main JS thread by using the NSolid thread metric class. And the second time, we will take a CPU profiler by using the NSolid CPU profiler class. Once the action is completed, a callback method will be called. From those callbacks, the recommendation is sending the data back to the agent thread we just created in order to interfere with the runtime threads as little as possible. Then, from the agent thread, we could do whatever we want with the data. For example, we can send it to a backend of our preference using whatever protocol is available. Focusing on the NSolid thread metrics class now, once we create a thread metrics object, we call the update method with the callback function and some optional arguments to be passed to the callback. When the actual metrics are ready for retrieval, the getThreadMetrics callback will be called. Then from the callback, we can call the get method to actually retrieve the metrics, which in this case, we serialize and send them to the agent thread. Looking now at the CPU profiler, we use the takeProfile method and pass the thread ID of the thread we're going to be profiling along with the duration and the done callback, which will be called when the profiling is over. From there, we send the profile string to the agent thread for processing. And basically, that's it. Now we build the add-on and run this basic script, and we can see that we're actually receiving the metrics first and then the profile data. Notice that a valid NSolid Enterprise license is going to be needed in order to be able to use the C++ API. Finally, we're providing a Prometheus agent add-on as a reference on how to implement an agent that takes full advantage of the C++ API. This add-on allows the Prometheus server to grab metrics from your NSolid runtime so you can display them there or in any other Prometheus-compatible backend solution. To showcase the add-on, I'm going to run the example that is available in the repository. This is a basic example of a web server that performs a CPU-intensive operation in worker threads that are managed by a thread pool. I will go into details on how this is implemented, but I will focus only on how we've integrated the add-on. The add-on defines an init method to configure the agent and a start method to start collecting metrics from the thread it's being called from. If we go back to the configuration, we can see 1. We're grabbing NSolid generic metrics every second. 2. The Prometheus server will have to connect a localhost 8080 in order to pull metrics from the runtime. And 3. For some specific NSolid metrics, we can define wherever we want to collect them as summaries or histograms. In this case, we're collecting garbage collection and HTTP server TX directions as histograms with the corresponding buckets. So now we're going to run the example. First, we start the Prometheus server. If we check the configuration, we can notice that localhost 8080 is set up as a target to pull metrics from. Remember that this address is the same as the one configured for the Prometheus agent in the example. Starting it now. Then I'll start the server example. And finally, I start sending some load to the server with AutoCannon. Then, if we go to the Prometheus server page, we can check that it's indeed pulling data from the runtime. So, for example, we can see how the HTTP server transaction directions are distributed in the respective buckets. Notice that I'm only interested in the main thread, thread ID 0, because of the HTTP server is actually running only in that thread. Or we can calculate the median of those durations over the last 5 minutes. So that's it! Thank you for taking the time to go through this video. I hope it's been interesting for you and you find this API useful. Also, don't hesitate to reach out if you have any questions. Bye!